right, 7.3 is titled Repeating Decimals. All of the decimals that we've dealt with so far have been terminating, or we've left them in fractional forms, okay? So we talked about the fact that there's certain ways to decide if a number terminates or not. It has to do with how the factors in the denominator after it's reduced sort of play out. And we're going to start actually right there. So when was it that we said that a fraction could be written as a terminating decimal? Do you remember? What does it take to make that happen? The denominator of what specifically, Brooke? The fraction? The simplified version of the fraction, if it simplifies, right. So when a fraction can be when can a fraction be written as a terminating decimal? It's when the denominator of the simplified fraction, or the reduced fraction, I'll say reduced, has only factors of 2 and or 5. It can have 2's, it can have 5's, it can have 2's and 5's, nothing else after it's been reduced. So what if the fraction can't be written as a terminating decimal? Well, then the fraction, then the decimal will repeat. So when that happens, the decimal will repeat. It may repeat the same number over and over again, like 3, 3, 3, 3, 3, 3. That could happen. It may repeat 4 numbers over again, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay? So, but it will repeat. There won't be any cases of values that are able to be starting out as fractions that can't do this. There are numbers that don't do this. One you're familiar with is the number pi, right? The number pi is irrational. It does not have a form where you can write it as an integer over an integer. And because it doesn't have that form, it will not have a terminating decimal form either. So those two things go hand in hand, right? Being irrational and not being able to be written in a terminating or repeating form are the same thing. We're not dealing with those kinds of numbers, and we won't in this class at all, okay? All of our numbers are able to be written either as a terminating decimal or a repeating decimal, okay? So what I would like to show you is how to go back and forth between those two representations. So this one right here is the number 1 over 24. It is in reduced form. How do I know? Because there's 1 on top, right? So I don't have to worry about reducing this. If it wasn't in reduced form, you're going to save yourself some work if you reduce it first. Okay, so start with a reduced fraction no matter what you're doing, whether you're turning it into terminating or repeating or whatever. Start with a reduced fraction. So when we're looking, just like we were with terminating decimals, we are going to divide what's on top by what's on bottom. So this is the number 1 divided by 24. And of course, that doesn't have a whole number value in it, so I've got a decimal point, and I'm going to be putting some zeros in here. And I don't know exactly how many I'm going to need, but I can keep tacking on more as long as I need them. 10 doesn't go into, 24 doesn't go into 10, as in 1, 0, but it will go into 100, right? So here's my decimal. I've got a 0 here. How many times will 24 go into 100? 4, yeah. So what is 4 times 24? 96 is correct. And if I subtract, what do I have? A 4, and then I'm going to bring my 0 down. Will 24 go into 40? Yep. How many times? Just once. 1 times 24 is, of course, 24, and subtracting gives me what? 16. So far, none of my subtraction steps have been equivalent to ones that I've seen prior to this. So we keep going. Okay, as long as there's sort of looks like there would be a remainder on bottom that's not a 0, we keep dividing. So I'm going to bring another 0 down. I have 160. How many times will 24 go into 160? 6. What is 6 times 24? 144. And if I subtract, what do I get? 16. Have you seen that before? The previous step right here had a 16, right? So at the point when the repeat starts, if it repeats immediately, like this one, 16 and then 16, then the last digit is going to continue to repeat. And if you think about it, and if you're not sure, you can just keep going, right? Bring down another 0. If I bring down another 0, I've got the 160 again. How many times will 24 go to 160? 6 times, right? So, I mean, you can see it happen if you're not sure, like, where's my repeating go? Just do a few more steps and you'll see it. But this value right here would be the decimal 0, 4, 1, and the 6 only would be the repeating part. So we don't want to do like lots of extra digits when they're not necessary to repeat. If the 6 is the only thing repeating, we put a 6 with a repeating bar. I don't need to put 66 in a repeating bar. That's not necessary, okay? Does that make sense? So what we're really looking for, sort of in the shortest form possible, is we're looking for a repeated remainder when I subtract. Once I get a repeated remainder, I will start having the repeated decimal on top.
Would you rather us do the little bar above, or would you rather us round?
Oh, you need the repeating bar above. Rounding is not going to work here. The whole point is that we're getting repeating decimals. Yeah. Okay. So we actually call this type of decimal a repeating decimal. The repeating block of digits is called the repeat end. So the repeat end on this one is 6. Okay, just 6, the repeat end. And as we're doing this, I mentioned this last time, I expect to actually see the division. I know you have calculators and I have no intention of taking them away. So can you confirm your answer with your calculator? But of course. But I expect to see the division steps written out, just like you would expect to see from your 3rd and 4th and 5th graders as you're working through something like this, okay? All right, so we're going to do one more example, and then we will pause on this lesson for today. All right, same kind of problem as before. We have 29 divided by 99, and you may actually know the answer to this one because you might. I can tell you what the answer is just looking at this one from other pieces of information that I know, but that's not the goal here. The goal is to show the work for it, please. So we're going to write 99 on the outside and divide the 29 on the inside. Of course, does not go in, so I put a decimal point and a 0. So how many times will 99 go into 290? 2. So what is 2 times 99? Yeah, sorry. 198, yes. And if I subtract, what do I have? 92. And I'm going to do my 0 and bring it down. How many times will 99 go into 920? What is it, Hannah? It's 9. Thank you, Beth Ann. Yep, it's 9. What is 9 times 99? 891. And what do I get right here if I subtract? 29 initially. 0 would be what I get afterwards and I pull it down. But do you see that same 29 that we started with showing up again? Okay, so let me show you what you can do if you recognize it early enough. If you recognize it early enough, what that means is that it repeated back to the beginning, which means the repeat end on this problem is both numbers. Again, if you're not sure or you're not sure what part is repeating, you can do the process again. So Kira said that if I bring down my 0, I'm going to have a 290 again. And I could do it again. How many times does 99 go into 290? Well, 2 times. And this is going to be 198. And when I subtract, I get 92. And if I pull down another 0, and I do it again, I get another 29. So you see, again, that same 29 showing back up again. So if you need to see a couple more steps to make sure you understand what's really repeating, by all means, do that. But if you recognize it more quickly and know what that means as well, feel free to to stop at that point. So this problem is 0.29 with the 2 and the 9 repeating. Word to the wise, do not make me guess what your repeating bar is actually over. Please make it very clear, all right? If I have to guess, you're probably just going to get it marked wrong, okay? No guessing on this one.